Today we are going to be talking about the difference between speed, velocity, and acceleration. So let's go ahead and title our page just that: speed, velocity, acceleration. I'm going to abbreviate because I ran out of room there. Okay, so these three words all seem to sound the same when you're talking about them. But in actuality, they are all very different. So we are going to break our page down into three sections so that we can write about the differences of the three. So your pages, break it down like this into three groups. All right, we are going to label the first section speed. We are going to label the second section velocity. And the third section acceleration. All right, let's go back up to the top. Let's talk about speed for a minute. First of all, we know speed tells us how fast. And we know that because we drive vehicles and things like that. Now, we know it is how fast, but the technical definition is the rate of change in an object's movement. So let's write that right here underneath speed. Rate of change in movement. So basically that's telling me how quickly does something change when it's in motion. And normally we measure speed in miles per hour. And in our cars it is written as mph. But in science we are going to measure it in meters per second, or we could do centimeters per second. You could even do meters per hour. So when you're writing this slash means per, and that's just shorthand so you do not have to write the entire thing out. Now, to determine an object's speed, we don't always have a speedometer in front of us, so we have to use the equation speed equals distance divided by time. So over here we're going to write down speed equals, and then we're going to write the whole words, distance divided by time. So that's basically saying how far did I go in how many minutes or time, which gives you speed. Now let's talk about velocity for a second. We're going to come back to speed. So velocity is pretty much what speed is, but we're adding something to it. So velocity is how fast and which direction. How fast and in which direction. So all velocity is doing is adding the object's motion. Where is it going? All right? So the technical definition is the rate of change of movement and then we're going to add in a specific direction. So it's actually very simple. If we were writing down something's velocity, an example would be 90 meters per second, and then we add in that direction, so we might say east. sometimes when you're watching shows where cops are chasing people, they might say the suspect is running east at 15 miles per hour on Main Street. So they're telling the cop exactly where to go by using velocity, speed with direction. And then the last one we're going to talk about today is acceleration. Now we know acceleration as speeding up. So if somebody says, hey, we're going to accelerate, you instantly think we're going to go faster. But the key thing about acceleration is it means a change in speed or a change in motion. So speeding up, slowing down, changing direction are all going to go under acceleration. Now, when we think of an object slowing down, we usually say things like they decelerated, because in Caesar's English, that prefix D means to go slower. So they decelerated. When all actuality, scientifically, it's all filed under the word acceleration. So if somebody goes, we need to accelerate, you need to ask them, well, how? Are we going to go faster or slower? Or are we going to change direction? You can also include in this stopping or starting, because if you are in a stop position and then you start moving, you've obviously accelerated. And if you're in a moving position and you stop, again, you've accelerated. Now, the difference between these three words is actually super easy. Speed is how fast. Velocity, you've got how fast with the direction. And then acceleration, main word here, change. That's the main thing you got to know. It's the change. Now let's concentrate more on speed for a second. So I'm going to ask that you turn to a new page, and I'm going to teach you a cheater's version of calculating speed. Or not necessarily a cheater's version, but a way to remember it. So let's title this one Calculating Speed. All right, so just a few seconds ago, we said that speed was distance divided by time. And we wrote that down in our notes. Now, I'm going to show you what we call the triangle method. So over here to the side, I want you to draw a big triangle. And we are going to split this triangle into 3 sections. The first section up here, we're going to put a D for distance. Over here, we're going to put a T for time. And over here, we're going to put an S for speed. Now, this triangle tells us a couple of different things. First off, if we think of it in like fraction form, the distance is at the top, and we have this line right here as if it's a fraction. So let's say I need to figure out speed. Speed, easily, if I could memorize it, is distance divided by time. But if I can't remember that, and I've got my triangle, and I can remember S, D, T, if I take my hand and I cover up speed, that's the one I'm looking for, I'm left with distance divided by time. So what if I said, tell me how long it took for something to get there? How long means I'm looking for time. So without even knowing an equation, I can use this triangle to figure it out. So I'm looking for time. How long? I cover up the t, and in this case, I'm now left with distance over speed. And remember, it's like a fraction, so this means to divide. So my equation for finding time is distance divided by speed. So let's add that one over here. Time equals distance divided by speed. Now, because there's 3 parts, there's one more thing I can find out from this triangle, and it is distance. I'm actually going to write that word out. And if I said, how far did the object travel? Far means distance, so I cover up my D. And in this case, I am now left with S, and it is next to T. And I want y'all to think about math. When 2 numbers or a letter and a number are next to each other in math, that means to multiply. So, distance is speed times time. So over here, let's write equals, and then we're going to put ST. So from this equation, I can figure out all 3 of my equations, or from my triangle, I can figure out all 3 of my equations. So again, if somebody said, how fast were they going? Cover up speed for fast, and you're left with distance divided by time. If somebody said, ooh, how long did it take you to get there? They're asking you time. Cover up the T, and you're left with distance divided by speed. And if somebody said, how far did you go? You're looking for distance, so cover it up, and you're left with speed times time. Pretty interesting way to calculate something or to memorize some equations. We're going to be using this today and the rest of the week in some labs and activities we're going to do. So you need to have these notes and these notes ready, okay, to help you out. So keep them out while you're working. So again, speed is how fast. Velocity is how fast something's going with the direction added, so north, south, east, west, right, left. And then acceleration is a change in the speed or direction. Okay, let's go on to the next activity.